So let's start by reviewing the 6 basic trig functions. Trig functions come in handy anytime you have a triangle, and you know some things about the triangle, like you know some angles or some side lengths, and you're trying to find out other things about the triangle, namely other angles or side lengths. So in order for this to work, you always have to be working with a right triangle. So you have to know that at least one of the angles is 90 degrees. The other two angles are then less than 90 degrees by definition. So you typically pick one of the angles to work with. You pick one as your reference angle, and you stick with it throughout the entire problem. It doesn't matter which one you choose, but it is important that you stick with it and you don't get yourself mixed up, because otherwise you'll be mixing up your sines and your cosines. You'll see that in a second. So once you've picked your angle, you label the side that's opposite to that angle as the opposite side. Then you label the smaller side that's adjacent to the angle as the adjacent side. And the bigger side that's adjacent to the angle is the hypotenuse. The hypotenuse is always the longest side on the triangle, so it's easy to spot. Once you've labeled your triangle, now you want to see what you can do with it. So situations are going to come up where you know the angle, and maybe you know the length of one of the sides, but you don't know anything else. And that's where trig functions come in handy. So for example, the sine function claims that for a given angle, the length of the opposite side over the length of the hypotenuse will be a constant value that never changes. Okay, so for a given angle, it's always true that the side opposite divided by the hypotenuse is constant, fixed, and known in advance, and that's the value of the sine. So the triangle can get bigger or smaller, but that ratio has to stay the same. If it doesn't make sense intuitively, here let's look at an example. If you punch sine of 30 into your calculator, and make sure your calculator is in degrees mode, not radians mode. So if you punch sine of 30 into your calculator, you'll get a value of 1/2. And what that means is that anytime you have a triangle with a side or with an angle of 30, the side opposite that triangle divided by the length of the hypotenuse will be 1/2. Here's what it looks like graphically. So you're given a right triangle with a 30-degree angle, and let's say you have an opposite side of length 2. Then that means, by definition, the length of the hypotenuse has to be 4, because the sine of 30 is 1/2, and 2 over 4 is 1/2. Now you can make your triangle smaller, but you still have to make sure that ratio stays the same. Otherwise, you're going to be changing the value of your angle. So if your hypotenuse is now length 3, then you know that the side opposite that angle has to be 1.5. Otherwise, it's not a 30-degree angle. Something like this doesn't work. You can't have a triangle with a hypotenuse of length 7, an opposite side of 2, and an angle of 30 degrees. That's just not a triangle. So what other functions do we have? Well, there's the cosine function, which does the same thing for the ratio of the adjacent side to the length of the hypotenuse. It works just like the sine function, only now you're working with the adjacent side instead of the opposite side. If you had chosen the other angle as your reference point, then the adjacent and the opposite labels would be swapped. So that's why it's important that you pick an angle and stick with it. And then last is the tangent function. And the tangent function describes the ratio of the opposite side to the adjacent side. It comes in handy when you don't have or care about the length of the hypotenuse. Sometimes you end up in the opposite situation though. Sometimes you don't know the angle. Sometimes you know 2 side lengths and nothing else. And the question is, what's the angle? Well, if you find yourself in that situation, you want to use the cofunctions or the inverse functions that are capable of taking a ratio and telling you what angle produced that ratio. So in this situation here, we've got the arc sine. So the arc sine takes an opposite side divided by hypotenuse and tells you what angle would have that ratio. So for example, arc sine of 1/2 is 30, because the sine of 30 is 1/2. The arc cosine works the same way. It just uses the adjacent side and the hypotenuse as its ratio instead of the opposite side and the hypotenuse. And ditto for tangent. Tangent's helpful when you have an opposite side length and an adjacent side length and you're trying to find the angle. So here's another simple example. Let's say your triangle has an angle of 30 degrees and a hypotenuse length of 10 miles. You're asked to solve for the side that's adjacent to the 30-degree angle. So in this case, since x is the adjacent side, it's the smaller side that's physically touching the angle, we're going to use the cosine function because it relates the length of the adjacent side to the hypotenuse for a given angle. We plug in our values. X is unknown. X is that length of the adjacent side. 10 nautical miles is 10 miles is what I wrote. 10 miles is the hypotenuse, and 30 is your angle. Rewrite this using algebra, solve for x, and you get a value of 8.66, which is the value of x.